Hey everyone, welcome to my channel. So in this video, we're actually going to be going over the last part of the college algebra final exam review that we've been going over. So in this part, we're going to be going over numbers 31 through 40. And if you missed the other parts 1, 2, and 3, I'm going to link all those parts in the description along with the question numbers that it covers. That way you can jump to those in case you missed those. And also in the description, I'm going to link the timestamps of each question that we go over and its topic. That way you can jump around in this video to questions you really need help with rather than sit, unless you really need to sit for the whole video. But with that being said, we're going to continue on with this final exam and go to question number 31. Alright guys, so for question number 31, it says solve the inequality x plus 3 all over 2x minus 5 less than or equal to 0. So I'm going to write this down real quick. Alright guys, so I wrote down our inequality, and as you see, our inequality is rational, meaning that we have variables in the denominator. So when this happens, what we're first going to do is just set the top and bottom equal to 0. So when we set the top equal to 0, we're just going to do x plus 3 equals 0, and then for the bottom we're going to do 2x minus 5 equals 0. And we're just going to solve for what those x values are. So for over here, we have x plus 3 equal to 0. We're going to subtract 3 on both sides. That will cancel out, and we'll get x equal to negative 3. And then over here, we're just going to add 5 on both sides. That will cancel out, and we'll get 2x equal to 5, and then we're going to divide by 2. And when we do that, we get x equal to 5 halves. Okay, so as you see, the values that we found is negative 3 and 5 halves. So the next step we're going to do is we're actually going to make a number line. So I'm going to make that real quick. Alright guys, so I made my number line, and what we're going to do is we're going to put the values that we found. So as you see, we found x equal to be negative 3 and 5 halves. So I'm going to put negative 3 right here and 5 halves. So what we're going to do is I want you to notice the sign. So I'm going to circle the sign. Okay, so if you look, our sign is a less than or equal to sign. So because it's a less than or equal to sign, what we're going to do is we're going to be using closed holes. However, there's a catch. Because this is a rational function, remember, whatever we have in our denominator is going to give us an undefined value, whatever the zeros are for the denominator. So what we're going to do is we're going to put a closed hole above our x equals negative 3. However, we're going to put an open hole above 5 halves since that 0 came from the denominator. So right here, I'm going to put a closed hole because that's a less than or equal to sign. However, because our 5 halves came from the denominator, I'm going to put an open hole because it can't be included in the solution. Next thing I want you to notice is that it's a less than or equal to sign. So this whole inequality is less than or equal to 0. This indicates that we want to find what values are going to be negative, essentially, or less than 0, which is negative. So what we're going to do is, with our number line, we're going to find a value less than negative 3, between negative 3 and 5 halves, and greater than 5 halves. And we're going to see which one of those values that we plug in is going to give us a negative value. So I'm just going to find what the first value I'm going to test is see what, I'll just call it f. We'll say f of negative 4. A value between negative 3 and 5 halves would be f of 0. And then we're going to test we'll do f of 3. And we're just going to see if those values are negative or positive. So I'm going to test those real quick. Basically, you're just going to plug these values, negative 4, 0, and 3, into our inequality x plus 3 over 2x minus 5. And you're just paying attention if those values are negative or positive. Alright guys, so I found what f of negative 4, f of 0, and f of 3 were. And when I plugged those values in, for f of negative 4, I got a positive value. For f of 0, I got a negative value. And for f of 3, I got a positive value. We're looking for where the values were negative. So as you see, it's negative where it's between negative 3 and 5 halves. Therefore, this is where our solution is going to come from. We're going to connect the dots. And basically lining this up in interval notation, because it's a closed hole, that translates to a bracket. Then we're going to write -3, comma, and then 5/2, and then parenthesis because it's open hole. And that's basically going to be our solution. And the answer choice that lines up with what we got is answer choice D. So D is going to be the answer to number 31. And now we're going to move on to question number 32. Alright guys, so for question number 32, it says solve the inequality x squared greater than 3x plus 28. So I'm going to write this down real quick. Alright guys, so I wrote down this inequality. So the first thing we're going to do is try to get all the, numbers to one side. So what I'm going to do that is subtract the 3x and the positive 28. So I'm going to do minus 3x and minus 28 and minus 3x and minus 28. And when we do that, this will cancel out, and then this will turn into x squared minus 3x minus 28 greater than, and then we'll be left with greater than 0. Okay, so the next thing that we want to do is we have x squared minus 3x minus 28, so we want to solve for what x is. So as you see, we have a trinomial, so what we're going to have to do is factor this. So remember, when we factor, the idea is to find two numbers that multiply to give us our last term, which in this case is -28, and two numbers that add to give us our middle term, which in this case is -3. So those two numbers would be, so we factor into x, and we'll have -7, and then x plus 4 greater than 0. -7 times 4 is -28, and -7 plus 4 is -3. So once we do this, we're just going to set our factors equal to 0. So we're going to set x minus 7 equal to 0, and x plus 4 equal to 0. And then we're just going to solve for x. So x will essentially be 7, positive 7, and x will be -4. So the next thing we're going to do is we're going to make a number line in order to find what our solution is. So I'm going to make a number line real quick. Okay guys, so I made our number line. So on our number line, we're just going to put what we found for x, which is -4 and 7. So I'll put -4 here and positive 7 here. So I want you to notice how for our inequality, it's basically a greater than sign. Remember, when we have a greater than or less than sign, that's going to be associated with open holes. So what we're going to do is we're going to put open holes above our solution. So I'm going to put an open hole above -4 and positive 7. And then the next thing we're going to do is, in order to find where our solution x squared minus 3x minus 28 is greater than 0, we're going to plug in values less than -4, between -4 and 7, and greater than 7. And we're just testing to see which one of those values are going to give us a positive outcome, because we're looking for values greater than 0, which means we're looking for everything that's positive. So an example would be, we're just going to, let's just call it f. We're going to say find what f of -5 is. F of 0 would be another value we can plug in. And we can do f of 8. And we're just finding which one of those values are positive. So essentially, you're going to plug these values into x squared minus 3x minus 28 and see which one is positive or negative. Alright guys, so when I plugged in those values, I got for f of -5, I got a positive output, and then for f of 0, I got a negative output, and then for f of 8, I got a positive output. So therefore, this indicates our solution. We're going to connect the dots. Basically, our solution is going to be -infinity, -4, and then 7 to infinity. And if we were to write that in interval notation, that would translate to -infinity to -4, parenthesis because it's open hole, and then union 7 to infinity. Both parentheses because remember it's a greater than sign, which translates to parentheses in interval notation. So basically our solution is going to be -infinity, -4, union 7 to infinity. And the answer choice that corresponds to what we got is answer choice C. So answer choice C would be the answer to number 32. Alright guys, so now we're going to move on to question number 33. Alright guys, so for question number 33, it says solve for x in the equation 8 to the 3x equal to 4 to the 5x minus 2. So I'm going to write this down real quick. Alright guys, so I wrote down the equation, and so we have 8 to the 3x equal to 4 to the 5x minus 2. So as you see, we're dealing with basically an exponential equation. So there's two ways to solve exponential equations. And one of the ways that we're going to use is we're going to find a like base. As you see, our base, for our bases, we have 8 and we have 4. What we're going to do is try to find a base where we can kind of change it up, but they mean the same thing. So we're going to try to find a base for 8 and 4 so they can have the same base. So for 8 and 4, if you think of something they have in common, think of the number 2. So if we wanted to get 8, another way to rewrite 8 is 2 cubed, right? So we can rewrite this as 2 cubed and then times 3x equal to. And another way to get 4 would be 2 squared. So we write that as 2 squared and then times 5x minus 2. Okay, so as you see, when we did that, we now have a like base of 2. And when this happens, what we can do is set their powers equal to each other. So we're just going to set basically the 3 times 3x equal to the 2 times 5x minus 2. So when we do that, that'll be 3 is 3x equal to 2 times 5x minus 2. And now we're going to solve for x. So 3 times 3x will give us a 9x equal to, we're going to distribute this 2 to 5x minus 2, and that will be basically 10x minus 4. And then we can basically subtract 10x. That will cancel out on this side. 9x minus 10x is going to give us a negative x equal to negative 4. And then we'll divide by a negative. And we'll get x equal to positive 4 as our solution. And the answer choice that corresponds to what we got is answer choice D. So the answer number 33 is letter D. So now we're going to move on to number 34. Alright guys, so for question number 34, it says combine the expression 2 times log base b of 3 plus 2 times log base b of 5x plus x, 5 plus x, minus 1/2 log base b of 9 into a single log. So I'm going to write this down real quick. Alright guys, so I wrote down this kind of expression real quick, and basically they want us to condense this into one logarithm expression. So when we condense, remember we're going to use logarithm rules. So the first thing I want to do is, you see we have 2 log base b of 3 plus 2 log base b of 5 plus x minus 1/2 log base b of 9. So remember, when we have numbers in front of our logarithm numbers, we can rewrite that to become the powers. So basically, this 2 right here is going to go right over here. And then this 2 here is going to go here. And then this 1/2 is now going to go over here. So when we write that, that will become basically log base b and of 3 squared now, plus log base b of 5 plus x squared, and then minus log base b of 9 to the 1/2. Alright, so the next thing we're going to do is we can actually kind of simplify this a little more. So as you see, we have log base b of 3 squared. We can rewrite that as log base b of 9. And then plus, this will stay the same, log base b of 5 plus x. I don't know why I keep saying 5x. 5 plus x squared. And then we can rewrite this as basically log base b of the 9 to the 1/2 is the same thing as saying the square root of 9. So I'm going to take the steps to simplify this a little more. So we have log base b of 9 plus log base b of 5 plus x squared. And then we can rewrite the square root of 9 will actually simplify to 3. So we can say minus log base b of 3. Okay, so we're kind of getting somewhere. Now, the next thing that we're going to do is remember when we add or subtract logarithms, that's the same thing as multiplying or dividing. So as you see, we have over here, we have log base b of 9 plus log base b of 5 plus x squared. So we're going to condense that so that they're being multiplied to each other. So we're going to rewrite that as log base b of, this time, is 9 times 5 plus x squared. And then we'll have minus log base b of 3. The next thing we're going to do is, as you see, we have log base b of 9 times 5 plus x squared. Then we have minus log base b of 3. So since we're subtracting our log base b of 3, that's really the same thing as dividing. Now we can rewrite that as log base b, and this time we're going to have 9 times 5 plus x squared, and then we're going to say divided by 3. Alright, and lastly, we can further simplify this more. You see we have 9 times 5 plus x squared all over 3. We can actually divide the 9 and 3 and reduce that. So when we reduce that, that would be basically log base b, and 9 divided by 3 is 3 times 5 plus x squared. And that will be our final answer. And the answer choice that corresponds to what we got is answer choice B. So B is the answer to number 34. So now we're going to move on to number 35. Alright guys, so for number 35 it says solve the equation log of x plus 8 plus log of x equal to log of x plus 18. So I'm going to write this down real quick. Alright guys, so I wrote this down. So we have log of x plus 8 plus log of x equal to log of x plus 18. So as you see, everything is in terms of log. So, and basically what I mean by that is everything is surrounded by a logarithm. So the first thing we're going to do is we're going to apply logarithm rules to the left side of our equation because we have log of x plus 8 plus log of x. Remember when we are adding, that's the same thing as multiplying. So we can condense this to one logarithm equation where we write log of, and then this time we'll say x plus 8 times x equal to log of x plus 18. So once we get to this point, basically because both sides are in terms of log, we have log of x plus 8 times x equal to log of x plus 18. What we can do is just set what's inside the parentheses equal to each other because they technically have the same bases. So we're going to set the x plus 8 times x equal to the x plus 18. So that'll be x plus 8 times x equal to x plus 18. And remember, you can only do this when both sides are in terms of logs, such as this. So now that we have that, we're basically going to solve for x. So the first thing I'm going to do is distribute this x to the x plus 8. So that will be x squared plus 8x equal to x plus 18. And then I'm going to try to get everything to one side so that equals to 0. So I'm going to subtract the x and the 18. And when I do that, we'll get x squared, 8x minus x is going to be plus 7x, and then we'll just have minus 18 equal to 0. And now we're just going to solve for x. So one thing we're going to do is because we have x squared plus 7x minus 18 equals 0, we're going to factor this because it's a trinomial. So remember, when we factor, we're finding two numbers that will multiply, give us the last term, which in this case is negative 18, and add to give us the middle term, which is positive 7. So those two numbers would be x, and two numbers that would multiply give us negative 18 and add to give us 7 would be plus 9, x plus 9, positive 9, and x minus 2. Positive 9 times a negative 2 will give us negative 18, and positive 9 plus a negative 2 will give us a positive 7. So once we get to this point, we're going to set each factor equal to 0. So we're going to do x plus 9 equal to 0 and x minus 2 equal to 0. And basically we'll get x equal to negative 9 and x equal to positive 2. Now, you might think we're done, these are the solutions, but no. One thing that's important with logarithm equations is you want to replug back in what the solutions you got to make sure there's no errors, because with logs, it's important that what you plug in doesn't evaluate to a negative solution or a negative inside the parentheses. So we're going to plug in negative 9 first into our logarithm expression. Okay, so we plug in negative 9, so what we're going to do is just evaluate that on our calculator and see what we get. So we're going to do negative 9 plus 8 plus log of negative 9. And as you see, when we do that, right off the bat, we don't even have to solve for the other side because you get a domain error on your calculator. The reason being so is, as you see, firstly, in our first one, we have negative 9 plus 8. Negative 9 plus 8 will give us a negative 1. We have a negative 1. We can't evaluate anything less than 1 with logarithms, so that will give us an error. And another one is we have negative 9 in here. We have log of negative 9, which once again, that's less than 1. So as you see, negative 9 is not going to be part of the solution. That's out. So now we're just going to plug in 2 into our original logarithm equation to see if it's good. Alright guys, so I plugged in 2 and 2 was in the clear. Both of them, it worked for both sides. There was no errors, and as you see, I kind of had to round it because I got like a long decimal, but for both sides it was about 1.301. So basically 2 is going to be part of our solution. Therefore 2 is going to be the solution to this problem. And the answer choice that will line up with this. Okay, so they basically just want to know if it's a positive or a negative solution. So the answer choice that's going to go with what we got is going to be answer choice A. There is one solution and it's positive. And as you see, 2 is positive. So A will be the answer number 35. So now we're going to move on to number 36. Alright guys, so for question number 36, it says solve to the nearest 3 decimal places 17 equal to 25 times 3 to the 0.04x minus 5. And it says the solution will lie in which interval? Okay, so I'm going to write this down real quick. Alright guys, so I wrote down our equation. So as you see, this is kind of like a exponential equation. So the first thing I want to do is I just want to isolate it so we can get it to just be set equal to 3 to the 0.04x. So the first thing I want to do is I want to add 5 on both sides. And 17 plus 5 is going to give us 22 equal to 25 times 3 to the 0.04x. So the next thing we want to do is, as you see, we have 25 times 3 to the 0.04x. So what we're going to do is divide by 25 on both sides. And when we do that, we'll get 22 over 25. And I'll just keep it as a fraction since that's basically the exact answer rather than in decimal form. So 22 over 25 equal to now just 3 to the 0.04x. Alright, so the next thing that we want to do is we want to get x out of the power. So in order to do that, what we're going to do is we're going to ln both sides. So we're going to ln everything. And when we do that, that'll give us ln to the 22 over 25 equal to ln to the 3 to the 0.04x. So once we do this, remember when we have logarithm or natural log rules, whatever is in the power, we can put it to the front. So we're going to take our 0.04x and raise it to the front, and that's how we're going to get our x out of the out of the power. So let me rewrite this. This will become ln 22 over 25 equal to 0.04x times ln 3. Alright, so then last thing we want to do is basically we want to solve for x, right? So what we're going to do is we have 0.04x times ln 3. So what we can actually do is just divide everything by 0.04 ln 3, since that's what x is being multiplied by. And when we do that, x will be equal to ln 22 over 25 all over 0.04 ln 3. And decimal rounded to 3 decimal places. I'm going to see what that is. Alright guys, so when I did that, I got negative 2.909 about, and they want to see which interval that is in. So the interval that answer choice is in is, let me see. So they have basically 5 intervals. We have negative infinity, negative 1. We have negative 1 to 1, 1 to 2.65, 2.3 to 5.6, and 5.6 to infinity. So the answer choice that would best fit for us, because it's negative 2.909, it would be answer choice A, because it's in the interval negative infinity to negative 1. And that would basically be our answer for question number 37. I mean 36, my bad. Okay, so now we're going to move on to number 37. Alright guys, so for number 37, it says how much money is in the account 12 years after investing $1,500 at 4% compounded monthly. Round to the nearest dollar. So I'm going to write down all the information that we need real quick. Alright guys, so I wrote down everything that just stood out to me. So basically, this is a compound interest problem, and because it says compounded monthly, we're going to be using the following formula, and I'll put that on the screen. So basically, they want us to solve for A, because they gave us what T was, which was 12 years, right here. So that's going to be our T. Our initial amount, it says that they invested $1,500 initially, so that's going to be our P. This is going to be our R, and our monthly is going to be our N. So we're just going to plug that all in. So we're basically going to find what A of 12 is equal to. We're going to plug in 1,500 for P, and then 1 plus our rate R. Remember, we need to convert our rate to a decimal, so we're just going to do 4 divided by 100, so that'll be 0.04 divided by. N is, it says monthly, so we're going to have N is going to be 12. And then we're going to have to the NT, which is just going to be 12 times 12. And then we're just going to plug that into our calculator and solve. Alright guys, so when I plugged this into our calculator, I got about $2,422.18, and they said round to the nearest dollar, and the nearest dollar round up to, or round down to, would be $2,400.22. That doesn't make any sense. $2,422. How about that? Okay, that sounds better. And the answer choice that lines up with what we got is answer choice E. So now we're going to move on to question number 38. Alright guys, so for question number 38, it says interest is compounding continuously at 3%. How long will it take for a $7,500 investment to grow to $12,000? Okay, so I'm going to write down the information that we need for this problem. Alright guys, so I wrote down everything we need for this problem. One thing that I noticed is that this is a compounded continuous problem. Remember, anytime you have the compound continuous, that has its own formula, and this is only when it's compounded continuously. And the formula is, how I like to remember, is PERT, and I'll put that on the screen. So we're going to be using this formula for that. Also, it says 3%. This is going to represent our R. It says it was initially $7,500, so this is going to be our P. This is going to represent our A, because they want to see how long it'll take to get 12,000. And I put a question mark by our T, because that's what we're solving for, because they want to see how long will that take, and that's currently unknown. So we're going to just plug in everything that we have into our equation. So basically our A is going to be 12,000 equal to our initial amount, $7,500, and then E. And then remember, we're going to convert our 3% to a decimal, so we're going to do 3 divided by 100, which is 0.03. And then our T. We don't know what T is. To solve for T, the first thing we're going to do is we're going to divide by 7,500 on both sides. And when we do that, 12,000 divided by 7,500 will give us 1.6 equal to, and then this will just leave us with e to the 0.03t. Now, the next thing we need to do is we need to get t out of our power. And remember, when we do this, we're going to ln everything. So we're going to ln both sides. And when we do that, that'll give us ln 1.6 equal to ln e to the 0.03t. Once we do that, we can bring our power to the front based on logarithm rules. And when we rewrite that, that'll be ln 1.6 equal to 0.03t to the ln e. Now, as you see, we have ln e right here. Ln e is 1, so we can technically cancel that out. And basically, we're left with ln 1.6 equal to 0.03t. So lastly, to solve for t, we just need to divide both sides by 0.03. And basically, our t is going to be equal to ln 1.6 all over 0.03. And to round that, and that's about 15.667. So the interval, it gave us like an interval of the time period. So we have for A less than 10 years, nope, because we got 15.667. For B it says 10 to 15 years. Ours is on the edge. We got a little over 15, so that wouldn't fit in our period. And then for C we got 15 to 20 years. So in this case, C would be our answer because we got 15.667. So it's just a little over 15, which makes it between 15 and 20. So C would be the answer, number 38. Alright guys, so now we're going to move on to question number 39. Alright guys, so for question number 39, it says if x and y satisfy the system of equations, and we have x plus 2y equals 0, and x minus y equal to -6, then x is equal to, okay, so I'm going to write this system of equations down. Alright, so I wrote down our system of equations, and remember with system of equations, there's essentially 3 ways we can solve for them, but I'm going to use one of the ways because since we have our x's and y's lined up, as you see it's x plus 2y equals 0, and then we have x minus y equals -6, I'm going to use the elimination method because it's just easy to use that. So remember, when we eliminate, the goal is to basically multiply one of the equations by a negative sign in order to cancel a variable out. So I'm going to basically multiply the bottom. I'm going to try to get rid of x, so I'm going to multiply the bottom by a negative. So when I do that, that will turn into x plus 2y equal to 0, and then times negative x plus y equal to positive 6. And now that we've done that, we can add these two together. So we have x plus a negative x, that will cancel out. And then we have 2y plus y, that will give us 3y. And then we have 0 plus 6, and that'll give us 6. And then now we can solve for y. So what we're going to do is divide by 3. And basically, 3y divided by 3 is going to be just y, and then 6 divided by 3 is just going to be 2. So we got what our y is. Now we just need to find what our x is going to be. So in order to solve for x, we're going to plug in basically what we found for y into, in this case, one of our equations. So I'm going to plug in basically we can plug it to any equation. We can do the top or bottom. So I'm going to plug it into the bottom equation, x minus y equal to -6. So for this one, over here, I'm just going to do x minus 2 equal to -6. And then that'll turn into x minus 2, basically get rid of the parentheses -6. And then we're going to do plus 2. This will cancel out and we'll get x equal to -4. And the answer choice that lines up with what we got is going to be answer choice A. Alright guys, so now we're going to move on to our last problem of the whole exam and of course of part 4, number 40. Alright guys, so for number 40 it says use synthetic division to find the quotient q of x when p of x is equal to x cubed minus 4x squared minus 8x plus 8 is divided by x plus 2. Then state if x plus 2 is or is not a factor of p of x. Alright, so I'm going to write down everything we need for this problem. Alright guys, so I wrote down everything. Basically, essentially what we're going to find basically the quotient, which is going to be x cubed minus 4x squared minus 8x plus 8 divided by x plus 2. And we're going to use synthetic division to find this. So remember, when we're using synthetic division, we're going to take the divisor, which is right here, and we're going to basically set that equal to 0. And that's going to give us x equal to -2. Once we do that, we're just going to write our -2 right here. And then I'm going to make this little, I like L shape. And remember, with synthetic division, we're going to write all the coefficients of our terms. So as you see, for our first term, we have x cubed. So there's nothing in front of the x cubed, so we're just going to write 1. Next term, we have -4x squared. So as you see, we have a -4 in front. So I'm going to write -4. Next term we have -8x, so we're going to write -8 because -8 is in front of that. And lastly, we're just going to write down the last term, which is just 8. Alright, so with synthetic division, the first thing we want to do is bring down our first little term right here, which is 1. And we're going to multiply that to the -2, so 1 times -2 is -2, and we're going to take that over here, write it under the -4, and add those two. -4 plus -2 is going to be a -2. I mean, my bad, -4 plus -2 is -6, my bad guys. So next thing we're going to do is we're going to take -6 and multiply it by the -2 over here. -6 times -2 is going to give us +12, so we're going to write 12 under the -8, and we're going to add those two. -8 plus 12 is going to give us a +4. And then next we're going to take our 4 and multiply it to the -2. So 4 times -2 is -8, and we're going to put that underneath our 8 and add those two together, and we'll get 0. So when we get 0, this indicates that x plus 2 is a factor of x cubed minus 4x squared minus 8x plus 8. So basically, this is going to be kind of like our quotient, which translates to, remember it's always going to be a degree less, so it's going to be x squared minus 6x plus 4. And the answer choice, basically this is going to be, let me write this. So basically our q of x is x squared minus 6x plus 4. And the answer choice that lines up with this is going to be answer choice D, because it says q of x equals x squared minus 6x plus 4, and therefore x plus 2 is a factor. So D is the answer to number 40. Alright guys, so that basically concludes this college algebra final exam review, basically for spring 2021 edition. So I hope these parts were all helpful, and as a reminder, if you missed any of the parts, I will link those in the description. I'll link parts 1, 2, and 3 in the description, so that way you can go to those in case you missed a part or anything. But that basically wraps everything up, and I just wish you guys luck on your final exams. You're almost done, you just gotta push through, and yeah, I hope you have a great end of semester, I guess. I hope your semester ends well and everything, and just give y'all a pat on the back because you're just almost there. And that's everything. If you were confused on anything or on the problems that I went over, leave it in the comments. I'll try to get back at ya. But yeah, that's basically everything, and take care, guys.